is James. I'm John.
I'm Alexi.
And our project for our 124 project is a motorized Etch-a-Sketch.
So here we'll go into how an H-bridge works and the reasons why we need an H-bridge. The main reason that we need an H-bridge here is because we need to be able to reverse the direction of rotation for our motors. In the case of the Etch-a-Sketch, this is so we can change the position of the cursor on the Etch-a-Sketch. So the way that an H-bridge works is basically that there are 4 switches. In this case, these switches are transistors. And depending on which switches are on or off, this will change the direction of the current through the motor. So in this case here, we have our voltage in and ground. With these 2 transistors on and these two transistors off, the current will flow in this direction through the DC motor, giving it one direction of rotation. On the other hand, if we turn these 2 transistors on and these 2 transistors off, so you can see that the current flows in the opposite direction through the DC motor, thus changing the direction of rotation on the motor.
So the way that this project got started is that I really just wanted to control something with motors. So that's how it got started. And then my colleague James, he said, hey, why don't we use it to control an Etch-a-Sketch? So that's sort of the beginnings of how this gets started. First thing that we had to do is get a motor driver board. This is the whole thing that allows us to interface between the motors and the propeller microprocessor. This took a lot of time, mainly because, as you can see, there are a lot of connections that can be made. And what this basically does is first thing it does is it protects the propeller board from high currents from the motors, and it also contains an H-bridge, which allows us to sort of reverse the directions of the motors.
Hi, my name is Alexi and I was responsible for the joystick. We use a joystick from Parallax, which contains 2 axes, which has 1 independent potentiometer per axis for reporting the position. As far as for the motion of left, right, up, and down, this would be the measurement of voltage per potentiometer. You can see right now it's going up, down, right, and left.
So for my part of the project, I use a motor control board to write programs in order to draw shapes, letters, and numbers. Each shape or each number consists of a series of straight lines drawn one after the other. These lines are drawn by running a motor in a certain direction for a certain amount of time, and through trial and error you're able to combine these lines, and as you can see on the left picture, I'll draw my name, and the picture to the right shows a simple number 5. You can bring in a little program to draw my name, and this is by essentially drawing a bunch of lines in certain directions. So based off trial and error, you can essentially program it to draw certain lines in certain directions, and eventually get so complex that you can draw your name with it. Well, along with letters, we also program it to draw numbers, and John suggested using the infrared remote in unison with the parallax propeller to be able to receive an input off of the controller or off of the remote and then draw whatever number he pressed.
Yeah, so for my Lab 9, I had wanted to code a remote to get data to a infrared or receiver. So in this case, let's draw an 8. And then we'll draw a 1. So here's a 1. And then finally, we'll draw a 7.